Sorry.
All right, guys, we are going over matrices again this week. So there's some parts that we have covered already. Some things are going to be new. Now, a matrice is an arrangement of numbers and variables in a rectangular pattern by columns and rows. And when we describe the dimensions of a matrice, it is always rows by columns. So this matrice here would be a 3 by 4. Now, one thing is new is we're going to talk about the elements. The elements are the individual numbers or variables inside the matrice. Since we call this matrix A, each element will be denoted by lowercase a. And the number that follows it, 2, 1, is row and then column. So A2, 1 is row 2, column 1, which is the element -1. So if we look at this first matrix here, A, which is -18, 6, 38, 9, -9, 22, what would the dimensions of this matrix be? 2 by 3, because rows, then columns. Down.
So it's 1, 2, 3.
So 2 by 3, down, then over. Down, then over. Now, if we want to find the value of element 2, 1, that would be in this matrix CA. It'd be second row, first column. And the second row, first column would be 9. Questions on this here? Let's look at the next one. What is the dimensions of matrix B? It has 3 rows and 2 columns, so it's a 3 by 2. Now we want to find the value of element B3, 2. So third row, second column is -1. Questions on this here? Certain matrices have special names. If it's just a single row, we call it a row matrix. If it has exactly 1 column, it's a column matrix. And if the rows and columns are the same, we call it a square matrix. And we call it a zero matrix if every element in the matrix is 0. Now, the next thing we're going to do is addition and subtraction. To be able to add or subtract matrices, the dimensions have to be the exact same. And if they are, then we can add the corresponding elements. So matrix A is A2 by 2, 16, 2, -9, 8. Matrix B is A2 by 2. So are the dimensions for A and B the same? Yeah. So that means we can add the corresponding elements. So we can say 16 plus -4. 2 plus -1, -9 plus -3, and 8 plus -7. And then we simplify, we just add them together. 16 plus -4 is 12. 2 plus -1 is 1. -3 plus -9 is -12. And 8 plus -7 is 1. And that's it. Questions on this here? B minus C. Well, matrix B, -4, -1, -3, -7 is A2 by 2. And we want to subtract from it matrix C, 8, 6, which is a 2 by 1. Are the dimensions of both of these the same? No, so this here is not possible. Because if they don't have the same dimensions, we can't add or subtract them. Questions on any of this here? A plus B plus A. We can indeed. If we want to plug this into the calculator, first thing we need to do is input matrix A and B for this here. So if we want to input the first matrix, we go second matrix, and then over to edit, and hit enter to input the information in matrix A. Matrix A is a 2 by 2. So we have 16, 2, -9, 8. Once we finish putting the information in, we go second quit. Second matrix. So we need to put in the second one. So we go over to edit. This time we're going to go down to matrix B. Matrix B is also 2 by 2. So -4, -1, -3, and -7. Questions on how to type these in? Second matrix. Put in the second one. Second matrix. Edit. We go down to B.
28, 3, -21,
Huh? Matrix. Edit. Go down to B. The second one. Do it again. Now to recall it, we go second matrix, and that first list that's given that says names lets us recall the matrices. So we'll hit enter for A. Plus, second matrix, we'll scroll down to B, hit enter. Plus, second matrix, we'll select A again, hit enter to give us A plus B plus A.
Yep. You got yours. You got it. I got you.
28, 3, -21, 9. Edit. Over. Nope. Yep.
Let me know when you get that.
Second quit. Second matrix. Enter. Plus. Second matrix. And we'll go down to B. Plus. Second matrix. Okay. Second quit. Second quit. Second matrix, because you need to put the second one in. Over to edit. B. Enter. So the second one.
You have to type B in this one.
Yep.
Make it a 2 by 2.
Enter. Second quit. Second matrix. So we need to recall the first one, A. So we'll hit enter. Plus. Second matrix. We recall B. Yep. Plus. Second matrix A. Enter. We get this. So if we want to do the next one, we can go second matrix A, 2 by 2, B, -3, 4, -9, -5. Go 2. -3, 4, -9, -5. Second quit, second matrix. B, which is also 2 by 2. -4, 12, 8, -7. Now this time it wants matrix A minus matrix B. So for any of these here, when we type it in, we just denote each matrix either as A and B in the calculator or C. So here we would denote this as A. This is B. Type it in and we get 1, -8, -17, 2. Questions on this here? Or do we feel comfortable with these here? Okay. Matrix, multiplying by a scalar. When we multiply a matrix by a scalar, we're going to multiply everything inside the matrix by said scalar. So here we're going to multiply each of the elements by 5. So we do 5 times -12, 5 times 8, 5 times 6, 5 times -16, 5 times 4, and 5 times 19. Our 5 times -12 would be -60. 5 times 8 is 40. And that's it. Questions on this here? So just like with addition and subtraction, we can plug this into the calculator. So for the next one, we would go second matrix edit. Now this next one is a 2 by 4. 8, 0, 3, -2, -1, -4, -2, and 9. Once we finish getting it typed in, we can say second quit. Now it wants -4 times our matrix. So we'll say -4, second matrix A, even though we didn't label it the same as what they told us it was as T, we can still do this here. And it tells us our matrix is this here. Questions on this one here? Now we can do addition, subtraction, and scalars at the same time. So if we want to find -4b minus 3a, we can do by hand, or I feel like you're probably going to do it in the calculator. So we can label a as 2 by 2. So -9, 12, 2, -6. Second quit, second matrix to b, which is also 2 by 2. -4, -8, 2, -3. Since we did indeed label these as A and B, and it wants -4, second matrix B, minus 3, second matrix A. Here. We get this here. Do make sure that the sign, because here it was asking us to subtract between the two, that you do put a minus and not a negative, because it will give you a completely different answer. Questions on adding and subtracting with scalars? We feel comfortable with these? And really up to this point, besides labeling or naming elements inside of matrices, everything else has been a rehashing of what we've done before. Multiplication is new. You can multiply two matrices if and only if the number of the columns in A equals the number of rows in B. If the columns of the first match the rows of the second, it tells us that we can indeed multiply. The resulting column or rows of the first by columns of the second is the dimensions of our new matrix. So if we look at this here, columns of the first, rows of the second, are they the same? Yes. And if the columns of the first match the rows of the second, it says that we can indeed multiply. So here we can do A times B. And the new dimensions are going to be the rows of the first by columns of the second. So since the rows or columns of the first was 4, rows of the second was also 4, it says we can indeed multiply them together. And their new dimensions will be 3 by 2. Questions on this here? Let's look at the next one. Columns of the first, rows of the second, are they the same? So this is not possible. We won't specifically have a test over it. We're doing this week, and then when we come back from Thanksgiving break, we're going into chapter 4. And chapter 4 for the books, the other books, the one we actually been using, is different than this one here. 1A, columns of the first, rows of the second, do they match? Yes. So it says, yes, we can multiply these. And the new dimensions would be? 4 by 2. How about 1B? No, because the columns of the first does not match the rows of the second, so this is not possible. Questions on any of this here? Now, I'm just going to go through the process of multiplying these with y'all. So, I do want to show you how to multiply these here. When we multiply two matrices, we go over and down. So to multiply two matrices, first row we go over, first column we go down. So we'd have 6 times -5 plus -3 times 3. Because they're both 2 by 2, so the rows of the second does indeed match the columns. Columns of the first does match the rows of the second, so they are multipliable. And the new dimensions will be 2 by 2. They'll also go over down, so we'd have 6 times -4 plus -2 times -3 times 3. Over down, over down. Then we do the same thing with the second one, over down, so -10 times -5 plus -2 times 3. And then lastly, we will go over and down again. So -10 times -4 plus -2 times 3. So we multiply matrices, we go over, down, over, down. Now at this point here, we can do some simplifying. 6 times negative 5 is negative 30. Negative 3 times 3 is negative 9. 6 times negative 4 is negative 24. Negative 3 times 3 is, again, negative 9. Negative 10 times negative 5 is positive 50. Negative 2 times 3 is negative 6. Negative 10 times negative 4 is 40. Negative 2 times 3 is negative 6. And lastly, if we combine like terms, we'd get negative 39, negative 33, 44, and 34. So that there would be the product of A times B. Second matrix, A is a 2 by 2. Negative 9, 12, 2. Okay, whatever. 2, negative 6, and this here need to be 12. Negative 9, 12, 2, negative 6. Second quit, second matrix. Matrix B. Oh, no wonder that looked a little weird. Helps if I'm on the right page. 2 by 2. Negative 5, negative 4, 3, 3. Second quit, second matrix. And you need to edit A to give us the right matrix. 6, negative 3, negative 10, negative 2. Second quit. Now second matrix A, second matrix A, second matrix B. Put them next to each other, it's understood that they are being multiplied together. And we get this here. What do we think this is going to be? Multiplication with matrices does not work both ways because we get different values. So when we multiplied, we got these multiplications here. If we flip it, negative 4, 3, 3, 6, negative 3, negative 10. And we do the first one over down. Well, we have negative 5 times 6 plus negative 4 times negative 10. They have more that they do. There's more processing power. Negative 3. So we can see here just by doing the first part of this multiplication, the negative 5 and 6 is the same, but instead of having negative 3 times 3, we now have negative 4 times negative 10. It's going to give us different values. Questions with multiplication? That's it.